welcome to this tutorial. Kindly make sure you subscribe so that every time we post a new tutorial you are the first one to get notification. Today we want to look at solution to Bernoulli ordinary differential equations. So how do we solve them? That's what you want to know today. Steps by steps you get to know how we solve this. So a Bernoulli equation is one of these forms. So if you get an equation of this form, that is definitely a Bernoulli equation. Bernoulli equation. So you can see the parts. Yes. So if n is equal to 0, the equation automatically becomes linear equation. It becomes linear equations. And if n is equal to 1, it becomes n equal to 1, you find it becomes separable equation, like in this case. N is equal to 1, we have a y here, okay. Then rearranging, first the arrangement and the last the arrangement, you find this equation here is separable. The separable equation is a separable DE. We know how to solve separable DEs from my previous tutorials. If you have not checked on that, kindly look at the link above and also check on that. Okay, so if n is not 0 and is not 1, we can transform n given DE of this form, which is a Bernoulli DE differential equation, to linear equation. We can transform them. How do we transform them to linear? So a Bernoulli will be solved as linear, but after transformation. So what do? We normally divide by y power n, and we get this equation 2. That's what we solved. Then we let z to be whichever is with px. That's y to power 1 over n. Then after that, having done that, it has now changed to linear. So now we can now apply now concepts of linear, solving linearly. So we let z to be that. So that dz dx is actually that. Okay. From here, differentiation. And equation 2 now, when we modify the equation 2 by negative n plus 1, we will get this. When we transform to that. So our interest, the reason we are multiplying by this negative n plus 1, we want to at least have dy dx, this part with the dy dx, to fit in a way that we can substitute it with dz over dx. So when the dz dx tells us on what integrating factor we are going to multiply our differential equation. So that's very key to note. Okay, so if you substitute back what you end, you will be able to see that's true, that is true. And this is now a linear equation, and from our previous tutorial we have solved DEs, linear DE. So kindly check on the linear DE that we have looked at previous tutorial. If you have a question on this also, kindly leave a comment down there and be able to check on them. Okay, let's look at an example. So we have this example here. This tells us this is a Bernoulli equation, Bernoulli differential equation, with the our n being equal to negative 3. So we divide by y equal to -3, that's the procedure, and we have this, we get this. Then next we take z to be whichever is with px, because our px in this case here is x. So what is with this is actually y power 4, so that is our z. Then we get the derivative of dz dy. Dz dy gives us this. So our question is, what do we need to add here to modify at that point so that it looks exactly like our d and dz dy? We will find that we lack our 4 here. So our main equation here will have to multiply by 4 every part, so that this part here will be just substituted by and dz over dy. That's very key to note. Okay, so if you look at this, if you substitute here, you'll find this is linear equation, and we know how to solve linear equations. So we find our u, and the u is basically given by that from our previous linear way how to solve linear equations tutorial. So if we do that, we have that, and then we have that also, which gives us this, and therefore our y, substituting the replacing z, we will get this is our equation. We will get that as the equation. So if you have a question on solving linear differential equations, kindly check on our previous tutorial. If there is still a question, leave a comment there. If you have a question that you have a challenge with, leave that question there. I will do it for you. And guide you on how we can solve that. So generally we have looked at from up to now, we have looked at first order differential equations, from separable, homogeneous, non-homogeneous, exact, and using the integration factor for exactness, linear differential equations, and Bernoulli equations. So what we have will discover in these first order differential equations is that Bernoulli equations are transformed to linear differential equations. If you use integrating factor for exactness, it will change a given d to exact de. And again, if you have a near homogeneous, you can transform it to homogeneous, and after transforming it to homogeneous, you can transform it to separable. So a near homogeneous solution are given based on the knowledge of separable differential equations, same as homogeneous differential equations. Bernoulli equation solutions are based on the knowledge of linear differential equations. So with that marks the end of today's lesson. Kindly subscribe, and if you have any question, leave it at the comment box down there. Thank you for your time.